بسم الله الرحمن الرحيم. Assalamu alaikum wa rahmatullahi wa barakatuh. Our lesson today is about rotation. Now let us start by definition. Let O be a point in the plane and theta be a real number. The transformation that associates to every point M a point M prime such that OM equal to OM prime and the angle between OM vector and OM prime vector equal to theta modulo 2 pi is called a rotation with center O and angle theta. Now geometrically here we have a point O, which is the center of this rotation, and we have a point M. Now here M prime is the image of M by a rotation of center O and angle theta, and here theta be an oriented angle. Now here we have to pay attention about two conditions: OM equal to OM prime and the angle between OM vector and OM prime vector is equal to theta. Now notation: the rotation with center O and angle theta is denoted by RO theta. When we see this notation, you have to know that we have a rotation of center O and angle theta. Now since M prime be the image of the point M by rotation R, we can write R of M is equal to M prime, and R of M is equal to M prime if and only if OM equal to M prime and the angle between OM vector and OM prime vector equal to theta modulo 2 pi. Pay attention about here we have two conditions. Now a rotation has two elements, center and angle. Now in the figure at right, here we have two triangles, ABC and A prime, B prime, C prime, and we have a point O. Here we can consider that OA is equal to OA prime and the angle between OA vector and OA prime vector is equal to plus pi over 2, since this angle is an oriented angle in an anticlockwise sense. So we can see that A prime is the image of A by a rotation R of center O and angle pi over 2. So we can write R of A is equal to A prime. By the same way, OB is equal to OB prime, and the angle between OB vector and OB prime vector is equal to pi over 2. So B prime is the image of B by the same rotation R of center O and angle pi over 2. So we can write that R of B is equal to B prime. By the same strategy, R of C is equal to C prime. Thus, the rotation of the triangle ABC is the triangle A prime, B prime, C prime by a rotation of center O and angle pi over 2. Now remember, if we have a rotation of center O and angle theta, R of M is equal to M, then OM equal to OM prime and the angle between OM vector and OM prime vector is equal to theta. Example 1. Let ABC and ACD be two direct equilateral triangles where O is the center of triangle ABC, as you see in this figure. Let R1 be the rotation with center A and angle pi over 3, and R2 be the rotation with center O and angle minus 2 pi over 3. Now part 1, verify that R1 of B is equal to C and determine R1 of C. Now here we have a rotation R1 of center A and angle pi over 3. In order to verify that R1 of B is equal to C, let us apply this remark. Here we have to show that AB is equal to AC and the angle between AB vector and AC vector is equal to pi over 3. Now it's easily from this figure we can notice that AB is equal to AC since ABC is an equilateral triangle, and the angle between AB vector and AC vector is equal to plus pi over 3 since it's in a positive sense. So we can say that R1 of B is equal to C. Now in order to determine R1 of C, here we have AC is equal to AD and the angle between AC vector and AD vector is equal to pi over 3. So according to this remark, we can say that R1 of C is equal to D. Now part 2, find R2 of B and determine R2 of C. Now here R2 be a rotation of center O and angle minus 2 pi over 3. In order to determine R2 of B, let us start by the point which is the center of R2, which is O. Now here, according to this figure, we have OB is equal to OA. Now let us make a few discussion about the angle AOB. Here we have that the triangle O. B is an isosceles triangle at O. So the angle OAB is equal to the angle OBA is equal to 30 degree. Then the angle AOB is equal to 180 minus 60 degree, which is equal to 120. But the angle between OB vector and OA vector, it's in a negative sense. So this angle is equal to minus 120, which is equal to minus 2 pi over 3. So we can deduce that R2 of B is equal to A. Now R2 of C, by the same way, we have that OC is equal to OB and the angle between OC vector and OB vector is equal to minus 2 pi over 3. So we can write that R2 of C is equal to the point B. Now part 3, find the rotation R3 with center C that maps D onto B. Now since C be the center of R3, so it's enough to find its angle, and suppose this angle be theta. Now since R3 of D is equal to B, then theta must be equal to the angle between CD vector and CB vector. Now according to this figure, the angle between CD vector and CB vector is equal to the angle between CD vector and CA vector plus the angle between CA vector plus CB vector, which is equal to pi over 3 plus pi over 3, which is equal to 2 pi over 3. Now part 4, find the rotation R4 with center A that maps D onto B. Now, since A be the center of R4, so it's enough to find its angle. Let theta be its angle. Now, since R4 of D is equal to B, then theta must be equal to the angle between AD vector and AB vector, which is equal to minus 2 pi over 3, since it's in a negative sense. Now, let ABCD be a direct square with center O. Let R be the rotation with center A and angle minus pi over 2, and small r be a rotation with center O and angle pi over 2. Now, part 1, verify that R of D is equal to B. Try to do it alone. Now, since R be a rotation of center A and angle minus pi over 2, now according to this figure, we have that AD is equal to AB and the angle between AD vector and AB vector is equal to minus pi over 2 since it's in a negative sense. So we can deduce that R of D is equal to B. Part 2, verify that small r of C is equal to D and determine small r of A. Try to answer it alone. Now, since small r be a rotation of center O and angle pi over 2, and since OC is equal to OD and the angle between OC vector and OD vector is equal to plus pi over 2, so we can deduce that R of C is equal to D according to this remark. Now, in order to determine small r of A, here we have OA is equal to OB and the angle between OA vector and OB vector is equal to plus pi over 2. So we can deduce that R of A is equal to B. Now part 3, find the rotation R prime with center C that transforms D onto D. Try to do it. Now since C be the center of R prime, then it's enough to find its angle theta. Now R prime of B is equal to D. This means that theta is equal to the angle between CB vector and CD vector. Now the angle between CB vector and CD vector is equal to minus pi over 2. So R prime C and minus pi over 2. Now part 4, find R round R of C. Try to do it alone. Now R round R of C is equal to R of small r of C, and small r of C is equal to D from part 2. So we get capital R of D, and capital R of D from part 1 is equal to B. Now application, let AB be a given segment. R is the rotation with angle pi that maps A onto B. Find the rotation R. Try to do it alone. Now since pi be the angle of the rotation R, so it's enough to find its center. Suppose L be the center of the rotation R. Now since R of A is equal to B, according to this remark, we can write that LA is equal to LB and the angle between LA vector and LB vector is equal to pi. Thus L is the midpoint of the segment AB. That's why here, since LA is equal to LB and the angle between LA vector and LB vector is equal to pi, so L must be the midpoint of the segment AB. Now application 3. Let AB be a given segment. R is the rotation with angle pi over 2 that maps A onto B. Find the rotation R. Try to do it alone. Now let L be the center of the rotation R. Now since R of A is equal to B according to this remark, we have that LA is equal to LB. Then L belongs to D, which is the perpendicular bisector of the segment AB. On the other hand, we have that the angle between LA vector and LB vector is equal to pi over 2. Then L belongs to C, which is the semicircle with diameter AB derived from A and B. Then L is the point of intersection between D and semicircle C. Now to understand well, let us see this figure. Here we have LA is equal to LB and the angle between LA vector and LB vector is equal to pi over 2. Then L is the intersection of D and C. Now why L does not move on whole circle? Since if we take L in this position here, then the angle between LA vector and LB vector is equal to minus pi over 2, which is not true since R be a rotation of angle pi over 2. Property. Let R be the rotation, center O and angle theta. Now R of A is equal to A prime and R of B is equal to B prime if and only if AB is equal to A prime B prime and the angle between AB vector and A prime B prime vector is equal to theta modulo 2 pi. Now example 2. Let ABC be a direct right isosceles triangle with the angle between AB vector and AC vector is equal to pi over 2 modulo 2 pi. R is a rotation that transforms A onto B and C onto A. Find the rotation R. Now let L be the center of R and theta be its angle. Now since R of A is equal to B and R of C is equal to A, then from this property we can deduce that theta is equal to the angle between AC vector and BA vector, which is equal to the angle between AC vector and minus AB vector, which is equal to pi plus the angle between AC vector and AB vector. Now since the angle between AC vector and AB vector is equal to minus pi over 2, then theta is equal to pi minus pi over 2, which is equal to pi over 2. Now let us find the center L of the rotation R. Now since R of A is equal to B, then LA is equal to LB. Then L belongs to D1, which is the perpendicular bisector of the segment AB. And since R of C is equal to A, then LC is equal to LA. Then L belongs to the straight line D2, which is the perpendicular bisector of AC. So we can deduce that L is the intersection of the straight line D1 and D2, which is the midpoint of the segment BC. Now application 4. Let ABCD and BEFC be two direct squares with center O and I. Now we have a rotation R that maps E onto B and B onto C. And we have also a rotation R prime with center A and angle pi over 2. And we have a translation by AB vector. Now part 1, find the elements of the rotation R. Now let L be the center of the rotation R and theta be its angle. Now since R of E is equal to B and R of B is equal to C, then theta is equal to the angle between EB vector and BC vector, which is equal to the angle between minus BE vector and BC vector, which is equal to pi plus the angle between BE vector and BC vector. According to this figure, we have that the angle between BE vector and BC vector is equal to pi over 2. So we get that theta is equal to 3 pi over 2 or minus pi over 2. Now let us find the center L. Since R of E is equal to B, then LE is equal to LB. Then L belongs to the straight line D1, which is the perpendicular bisector of the segment BE. And since R of B is equal to C, then LB is equal to LC. So L belongs to D2, which is the perpendicular bisector of the segment BC. So we can deduce that L is the point of intersection of D1 and D2, which is the point I. Part 2, determine R round T AB vector round R prime of B. Try to do it alone. Now R round T AB vector round R prime of B is equal to R of T AB vector of R prime of B. Now let us find R prime of B. Here R prime be a rotation of center A and angle pi over 2. So according to this figure, we can consider that AB is equal to AD and the angle between AB vector and AD vector is equal to pi over 2. So we can deduce that R prime of B is equal to D. Now the translation of the point D by vector AB is equal to C, so we get R of C. Now since R is a rotation of center I, here we have IC is equal to IF, and the angle between IC vector and IF vector is equal to minus pi over 2. So we can deduce that R of C is equal to F. Now let R be a rotation with center O and angle theta that maps A onto A prime, B onto B prime, and so on. Now the rotation R of center O and angle theta preserves collinearity. Now according to this figure, we have that the 3 points C, E, and B are collinear. Now since rotation preserves collinearity, then their image by the rotation R are still collinear. So C prime, E prime, B prime are collinear. Now also rotation preserves the midpoint of a segment. Here we have I is the midpoint of segment AC. Then the rotation of the point I is midpoint of the rotation of the segment AC. So we can deduce that I prime is the midpoint of the segment A prime, C prime. Now rotation preserves parallelism. In this figure we have that IJ is parallel to AB. Then the image of IJ is still parallel to the image of the straight line AB by the rotation R. So I prime J prime is parallel to A prime B prime. Now also rotation preserves orthogonality. Here we have that CH is perpendicular to the straight line AB. Then R of CH is still perpendicular to R of AB. Then we can deduce that the straight line C prime H prime is perpendicular to the straight line A prime B prime. Now rotation preserves the measures of the oriented angles. Now since here the rotation of the segment AB is equal to the segment A prime B prime, and the rotation of the segment AC is equal to the segment A prime C prime. So the angle between AB vector and AC vector is still equal to the angle between A prime B prime vector and A prime C prime vector. Now rotation preserves area. Now the area of the triangle ABC is equal to the area of its image by the rotation R, which is equal to the area of the triangle A prime, B prime, C prime. Now rotations also preserves distances. Here we can write that AB is equal to A prime, B prime, and IJ is equal to I prime, J prime, and CE is equal to C prime, E prime. Now rotation preserves shape. Since IJBA is a trapezoid, then the rotation of this trapezoid is still a trapezoid. Then I prime, J prime, B prime, A prime is a trapezoid. Now Mira or Rami. Here we have 3 direct equilateral triangles, and we have a rotation R of center D and angle minus pi over 3. The question here is how to determine R of A. Now Mira wrote that dA equal dB, and the angle between dA vector and dB vector is equal to minus pi over 3. So she wrote that R of A is equal to B. While Rima wrote that R of A is equal to E, since dA equal dE, and angle between dA vector and dE vector is equal to minus pi over 3. Now I think Mira's answer is incorrect, since the angle between dA vector and dB vector is equal to pi over 3, not minus pi over 3. Then Rima's answer is the correct.